Very good morning to all of you. Today we will be touching on a new topic, how to solve equations involving modulus function. The kind of modulus function we will be touching on, or equation that we'll be touching on, will be of this form. A mod g of x plus c equals to mod f of x. Now where g of x and f of x are linear functions. Now, if you learn this technique, you can extend to non-linear function. There's two methods to solve this kind of equation, or at least two. One is do it by graphically, the other is doing it by algebraically. Now, today I will emphasize on graphically. Now, in the earlier chapter, I teach you how to sketch a modulus function. Where I emphasize that you need to indicate the x-intercept, the y-intercept in the turning point. Now, if you are given an equation, but you are not asked to sketch, but you are asked to solve, then there's no need for you to indicate all the critical points because you are only using the graph to help you in this solution. So what are the key points to take note when you do a sketch of a modulus function? Now, one, you must find the y-intercept. Y-intercept. Now, let's say you want to sketch this graph. Y is equals to A mod bx plus c mod plus d. Now, what you can do is you just put x equals to 0. Alright, then your y will be equals to a mod c plus d. Please don't memorize this expression, just put x equals to 0. Otherwise, you find that you have too many things to remember. Okay, just do it intuitively. You put x equals to 0 because anything on the y-axis, the x coordinate is 0. Now next, you need to indicate where is the minimum point, or rather where is the what is the coordinate of the vertex of this modulus graph. Now, the vertex will be, the x coordinate of the vertex will be given by minus c over b. The y coordinate will be given by d. Now, I want you to compare this to your completing the square for your quadratic graph. Let's say you're given a quadratic graph. Y is equals to a bx plus c squared plus d. What is the turning point for this quadratic function? Now you learn the coordinates will be x is equals to minus c over b, and your y coordinate will be equals to d. So it's kind of identical. Now, so if you can remember your quadratic function, right, you can also use that knowledge for your modulus function. Now, you may not know why these are the turning points. Let me show it to you. Let's say you are given the function is y is equals to a bx plus c squared plus d. Now let's take if a is greater than 0. Now if a is greater than 0, then a into bx plus c whole thing squared will be greater than or equals to 0. Because when you square an expression, it will always be positive or 0. So you multiply by a a number greater than 0, all right, this will be greater than or equals to 0. Then you add d to it. So now the minimum value will be d. Okay? That means this graph, all right, your minimum value will be d. Okay? This is the x coordinate. Your graph will look like that. This is the minimum. It cannot be turning this way. That's why when a is greater than 0, you are taught that this looks like a smiley face. Okay? Smiley face. Now, what is the x coordinate for this turning point? It will be minus c over b. Why? It will be minimum when this part is 0. This part is 0. Alright? Minimum when a into bx plus c is squared equals to 0. But when will this be equals to 0? When bx plus c equals to 0. When x is equals to minus c over b. So your this coordinate will be minus c over b. Does it make sense to you now? Now, let's turn our attention back to modulus function. Let's say you are given this modulus function. Y is equals to a modulus bx plus c plus d. Now, if a is greater than 0, then a into mod bx plus c will be greater than or equals to 0. Then a into mod bx plus c plus d will be greater than d. Now, so similarly, the minimum point will be, or the vertex will be given by d, your y coordinate. Alright, when will the minimum happen? When x is equal to minus c over b. Okay? Now let's do the case when if a is smaller than 0. Now if a is smaller than 0, then a times mod b of x into mod bx plus c will be smaller than or equals to 0. Okay, because you mod a number is always positive. You multiply by a negative number, it will always be negative. But of course, this one can be 0 as well. That's why it is equals to 0. Now, so you add d to it. So a into mod b plus c plus d will be smaller than or equals to d. Smaller than or equals to d. So your function will be like this, all right? So this point will be d. All right? Now, when will it be at the peak? When this is 0. When this is 0. So you equate bx plus c equals to 0 and you get x is equals to minus c over b. Okay? Now, so these are the two things that you need to know when you are doing a rough sketch for a modulus function to help you in solving your modulus equation. Okay, let's move on to some examples. Question 1. Mod 2x minus 3 equals to 4. Now, I have no objection if you just put 2x minus 3 equal plus minus 4, you solve, because this is rather easy if you solve it algebraically. But as you go on, you find that some of the examples you find very hard, especially when it comes to inequality, which I will be doing a video on it also. Now, when it comes to inequality sign instead of equal, I suggest you do it graphically and try not to do it algebraically. Otherwise, there's a lot of things to consider and you might make mistakes. So it is a good experience that you learn how to do it graphically first. So let's draw this graph. Where does it cut the y-axis? You put x is equal to 0. Alright, then you get mod of minus 3, which is 3. So let's say it's somewhere here, 3. Now, what is the minimum point? Alright, the minimum point will be, the x will be, you equate this to 0, you get x is equal to 3 over 2. So let's say 3 over 2 is here. Alright, so your graph will be, let me use a different color. Something like that. And then this one is a V shape. Okay? Now, and then you draw the line y equals to 4. Let's say 4 is here. So this is the line y equals to 4. So they want to find these two intersection points. Okay? Now, what is the equation for this graph, for this part of the graph? Now, this is a positive gradient, so this part will be represented by y is equals to 2x minus 3, and this one will be represented by y is equals to minus 2x plus 3. Okay? Now, to solve this, all you need to do is you equate this to 4 and you equate this to 4. So let us do that. So you have minus 2x plus 3 equals to 4, or 2x minus 3 equals to 4. Okay, you solve this, you get x is equals to 7 over 2, and this is x is equals to minus half. Right, so your final solution is x is equals to minus half, or 7 over 2. Now it's quite simple, right? This example. Now let's move on to example 2. Now let's try to draw this graph first. Where does it cut the y-axis? You put 0 and you find that it is at 8. X is 0, you mod of minus 8 is 8. So let's say this is 8. Alright. So where is the minimum point? Alright. The minimum point is at 8. So let's say this is 8. Alright, so it's a V-shaped graph because it's a modulus. Okay. Now let's draw this graph. It cuts the y-axis at 19, you put x is 0, let's say 19 is somewhere here. Now, where did it cut? Where is the minimum point? Alright, you have minus 19, so x is minus 19, so let's say somewhere here. Now please take note, these two has the same gradient, so you must make sure you draw more or less looks parallel. Alright. Now, there's one intersection here. Okay. Now, does it have another intersection here? No, because these two lines are parallel. Okay. And these two is parallel. So, there is only one intersection point that is here. Now, so what is the equation for this part of the graph? This is equals to, now this is negative gradient, so this is y is equals to minus x plus 8. And what is the equation of this line here? This part of the line, this is y is equals to x plus 19 because it has a positive gradient. So all you need to do, you equate these two equations. So you have x plus 19 is equals to minus x plus 8. Then you got 2x is equals to minus 11. This is 19. Okay. X is minus 5.5. So it's, or you can write it as minus 11 over 2. Okay. For that, let's move on to question 3 and question 4. Question 3, mod 2x minus 5 equals to modulus x plus 7. Now let's sketch the graph modulus 2x minus 5. Now where does it cut the x-axis? You put x equals to 0, you get mod of minus 5. Mod of minus 5 is 5. So let's say 5 is here. Now what is the minimum point? The x-coordinate of the minimum point is 5 over 2 or 2.5. And is on the y-axis, x-axis I mean. So let's say this is 5 over 2. Okay, so this graph will look something like this. All right. Now this is y is equals to 2x minus 5. It has a positive gradient. This has a negative gradient. So this part is y is equals to minus 2x plus 5. Now let's draw this graph now. Now you have modulus x plus 7. So it cuts the y-axis at 7. So let's say 7 is here. Now the coordinate of the minimum point is minus 7, 0. Alright, so this is minus 7. So you have a line that is a lot more gradual than this. This has a gradient of 2, whereas this has a gradient of 1. Alright, so let me draw this. Okay, now you'll find that there's 2 turning points. One of them is here. The other one, if I extend, alright, it will be somewhere here. Okay, whereas this one is diverging, so there is no intersection between this line and this line. So how to find the intersection of the 2 points? Very simple. You equate this graph to this graph. Now what is this equation of this graph? This is given by y is equals to x plus 7. Okay. So you have minus 2x plus 5 equals to x plus 7. Okay, you bring the across to this side, so you got 3x is equals to minus 2. So x is equals to minus 2/3. Alright, so this part is minus 2/3. How about this intersection? Now this line is x plus 7 and this is 2x minus 5. So you have 2x minus 5 equals to x plus 7. Then you have x is equals to 12. Yeah. So you have 2 answers. So your final answer is x is equals to minus 2/3 or 12. Let's move on to question 4. Question 4. Mod 6x plus 5 is equals to modulus x minus 7 plus 2. Let us sketch this graph first. Now what is the vertex? The vertex will be at x equals to 7 and the y coordinate is 2. So let's say 7 is here and this is 2. Now, what is the y-intercept? You put x equals to 0, so you got 9. So let's say 9 is somewhere here. So this is the graph for mod x minus 7 plus 2. Now next, let's draw this. Now it cuts the y-intercept at 5. So let's say 5 is somewhere here. Now what is the minimum point? It happens when x is minus 5, 6 and y is 0. So you got minus 5, 6 here. So your graph will look something like this. Alright. Now you find that this is a lot steeper than this. Now there will be two intersections. One is here. The other one will be further up here. Now, so what is the equation for this graph? This has a positive gradient. So your equation for this part of the graph will be y is equals to 6x plus 5. This will be y is equals to minus 6x minus 5. Now this graph has a negative gradient. So the equation for this graph will be y will be equals to minus x plus 7 plus 2. So it's minus x plus 9. So let's find the intersection of this one. So it will be 6x plus 5 is equals to minus x plus 9. That you get 7. And you get 4 here. So x is equals to 4 over 7. So this point here is 4 over 7 for x. Now let's find the intersections of another point somewhere up here. So here you get minus 6x minus 5. Now it's equals to, what is the equation of this line? This line is minus x plus 9. You plus x on both sides, so you got minus 5x. And then you plus 5 on both sides. And here you get 14. So x is minus 14 over 5. So your final answer is x equals to 4 over 7 or minus 4 over 5. Alright. For that, we have come to the end of this video. Now if you like our video, please press the subscribe button. Thank you for watching and have a nice day.